Hello everyone, this is the part 2 video on Openshift for Mass Administrators. In part 1, we were looking into the foundational architecture for Openshift. We discussed about the fundamental component that makes up the Openshift control plane, where we talked about the API services, config manager, etcd database. Then we moved into discussing about how these architecture works together to make up your cluster, and we also started looking into the major component that a mass administrator should understand and manage during the operation or installation of OpenShift or any various applications. We talked about ports, services, ingress, and I discussed about how the IP addresses get assigned to a pod and what are the advantages of services and ingress. We talked about two types of services, external services and internal services, and I a little bit updated the architecture diagram to show here how the URLs are different for services and the ingress controller. If you remember my discussion about the services, I mentioned that the service is independent of the pod lifecycle. A pod can die and it can be recreated, restarted. Every time that happens, the pod actually get a new IP address. That's where the service comes into picture, where we assign a service to a specific pod, and that service is static, right? It's a static IP address. So if you look at the bottom, you can see normally the service is like this. You have the node IP, HTTP, node IP, and then the port. But as I mentioned, the node is in OpenShift, a node is ephemeral. That means we can lose a node, right? We can add a new node. Sometimes ports get evicted from a node and move to another node. So all these things can happen dynamically. So sometimes the services may be running in node 1, it may be running in node 2. So that is where the ingress control, right? And also it's very not easy for us to remember this node IP address and use as a URL. That is where the ingress controller or ingress service is coming into picture, where you can actually use your subdomain or domain that you assign to OpenShift to point to a specific service within your application cluster. In the case of the home or admin subdomain, that goes to specific URL or context within the mass core or administrator or mass core home, it will be redirected based on your domain and context. So that's all about the pod, the application container image, how the IP address is getting assigned, how you create a service, and how the services are bind to an ingress or ingress controller. Now the next two components that we should be knowing is config map and secrets. These are two major services or components of OpenShift, and as when you deploy an application or when you develop a container based application, these are the two major components that you should be aware. The config object provides a mechanism to inject containers with configuration data. So most of the application you want to pass properties like the DB URL or some kind of configuration data that you want to disconnect or detach from your application container image and provide them as a common entry point or common injection, right, into the container. Because you can have multiple pods running in multiple worker nodes using the same configuration data. You always define, when you talk about the deployment, you see the deployment object here, you'll understand how the pod is being created, how the configuration data or config map data is being used. So config data is nothing but it's kind of a key value pair where you define your properties. The configuration artifact should be decoupled from the image content in order to keep containerized application portable, right? So you have your application, your container image, you have the config map where we have the context or the property that your application needs to read, and when the pod is running, that works together. And when you scale a pod, when you create a multiple pod instances, the same config data is used by the same application. So that's all defined in your deployment. So now that is a config map example. If you look at the example I have given, the MongoDB URL is a config map. So you will find a URL to your MongoDB and the port for the MongoDB where it's running available in your manage app or mass core app config map. So when the mass core pod is created, it is always referenced to that config map where the MongoDB URL is available. That's why when the pod is able to connect to MongoDB to read and write information. So similarly, secret is another property file, I'll say, but it's a configuration kind of object in OpenShift world, where you keep sensitive information like your password or your TLS keys are all kept in the secrets. See, similar to how you read the config map from the during runtime, you can read the secrets. To suppose you want, when that pod loads, it want to connect to the MongoDB. So it goes to config map, find your MongoDB URL, it goes to your secrets, find the password. Right? So that's all about secret. It just again sensitive information kept, but it's just a base 64 encoded. By default, OpenShift doesn't encrypt your secret. If you want to encrypt your secret, there are other options like third-party tools that you can use to encrypt your secret and decrypt at runtime. So you have by default doesn't happen. So that's about the secrets and config map. So you can see here the config map holds configuration data for pods to consume, right? So when you create a pod, you define your config map, it holds all the configuration data for the pod to create or consume during runtime. Secrets, a mechanism to hold sensitive information such as passwords. That is all about secrets. Also, you need to note that if you are changing your secret, you have to restart your pods, so that the pod's initialization happens and it reads all the latest and greatest from the secret object, and it populates the pod for the container runtime. So you need to make sure if you are changing the secret, you have to restart your pod, otherwise it won't take effect. Another object which is major here is the deployment. So deployment is a blueprint of a pod for deployment. It also defines how many replicas of for pod is required. As an application developer, all that you do is create your application, bring all the libraries that it's needed for runtime, make a container image out of it, put it in a registry, container registry. Then you come to OpenShift or any orchestration platform, you define a deployment YAML file. So deployment YAML file, you define how to create the pod and how many replicas of pod that you need to run, right? Take an example. Suppose if you are developing a web application, you create the application. If it's in a Tomcat, you bring all the libraries for Tomcat, all the configurations are assigned in your application configuration. Then some of the URLs or the properties are defined in the config map. You define the config map, you package all the into a container image, put in a registry, right? Then you come and define your deployment file and you just deploy, and rest of the stuff OpenShift take care of. So you never ever deal with images or the pod within OpenShift. It's all taken care by the platform. So deployment is again is a bit complex once you understand it. It's simple like writing any YAML file, but you need to understand there is a construct for defining deployments, but it is one of the important stuff as an application developer. You need to understand how to bring everything that you've done so far together into one file and make command to your orchestration platform to properly deploy within your cluster. Right? So that's the importance of deployment. I will make another video on the deployment and config map to just deep dive how to define a config map and deployment file as an example. Another service here is the stateful set. Stateful sets are for stateful applications. If you remember, I talked about deployment. Deployment are for stateless application, right? So manage app is stateless. That means you can create multiple ports of manage app, and you can just remove all of them, or you can recreate whatever you want to do. You can do with it. It's stateless. It doesn't keep any state. But if you look here, we have MongoDB. It's a stateful application. That means it's a database. It has a volume or data store. Even if you replicate the MongoDB to 3 ports in a 3 availability zone, it still has to coordinate each other to perform the read and write to a single volume, right? You cannot read and write from different ports, so because that will be data inconsistency issue will come. Just to be clear, suppose I have 2 ports of MongoDB running, and if it is independently handling its volume, then we will have data inconsistency. One Mongo pod is trying to write, another trying to read, and you may get wrong data, wrong information. So it is not possible, or it is not good to create a stateful application like MongoDB, MySQL, or Elasticsearch, or anything, right? It's to using deployment. That is where the stateful set comes. So stateful set is like deployment. Again, it's a YAML definition. I will show an example how actually a MongoDB stateful set YAML is defined, and how the OpenShift is going to use that to create a Mongo pod, and it's how that stateful set is being used to make sure one volume is read and write and attached to corresponding pod. You don't have to worry about all those mechanism behind the scene, but still you have to define the volume, the stateful set definition for MongoDB. It's not only for MongoDB, any application that even if you are developing which is a stateful application, you have to create a stateful set. But defining stateful set is not as easy as deployment. So that's why generally if you are a stateful application like DB or MongoDB, it's ideal you can keep it outside your cluster. If you're deploying DB2 as a clustered environment within the cluster, there is an option where you can say when you install mass, you can tell, okay, deploy it part of the cluster, right? Or you have an option to say, I already have a dedicated DB outside your cluster, and I'm going to use that URL, DB URL, to connect. So that you have an option. If you're deploying your DB2 as a cluster within the cluster, then it's a stateful set, because even though you have 3 DB2 pods running, still it has one volume, one database to handle, right? So that is where the stateful set comes handy. But it's not that easy to define that stateful set, and it's not a good architecture. Personally, I don't feel comfortable running my critical database part of cluster. I want a dedicatedly managed external database where my cluster is pointed. But it's still perfectly fine to run your DB2 within your cluster, right? There is nothing wrong with that. Last but not least is daemon set. Daemon set is used where you want to deploy pods in all the worker node under your cluster. As an example, suppose you want to install or deploy a monitoring agent. So there is no way the monitoring agent or monitoring probe can live in one of the worker node. It has to be in all the worker nodes. So that is where the daemon set is used. So you define a daemon set for pods that need to be deployed to all the worker nodes. It also automatically assign pods or deploy pods when a new worker node is added into your cluster. Suppose you add a new worker node or remove a worker node, the daemons is automatically adjusted accordingly. So this helps us to define a contract like how many pods and that needs to be deployed across the worker node under your cluster. Better example is the monitoring agent or background process or logging event, and those kind of pods you define as a daemon set, and once the definition is done, the platform will automatically create the pod and deploy across your available worker node.